Hi everyone, my name is Zuzhan from Pynest. Working with data is always a hot topic. Some people try to minimize transmitting data and think that the more aesthetic the message looks, the better. Oh, how much we sometimes have to read and collect because of all this atomicity. Others, on the contrary, try to cram everything into an array and then iterate over it. And so you sit there, you get a fish file. You look at it and somewhere in the middle of the file you realize that you don't remember where it all started, what you are doing and why you need it all in the first place. How to behave for such situations? Let's find out. Option 1. We have a bunch of disparate data linked by some keys. This is a quite common practice, especially when we talk about databases. A good example would be the use of an event-driven approach when developing an application. Here, we often have a huge number of Kafka topics that store events and various information about them. The idea is to decompose all available data into entities so that each entity has a definite nature. What does that mean? Well, if it's simple, don't put all your eggs in one basket. Everything should be in its proper place. Sounds cool, but there is that but again. And they say everything that came before doesn't matter, generally speaking. But when following such an idea often disperses to hundreds or thousands of different entities that quite differently, swim differently, look different. And what you need to do something about it. It's a painstaking, rumor-mongering kind of jump, and it's like, hey Alex, did you know that Jay is friend with Carl and Carl knows Alice? It sounds fun that way. What you might realize from that, and what you might realize, is that there is connection between Jay and Carl Alice. There is link in the form of Carl, so Jay can connect with Alice. Ha! That's worked out well. Now for our task we need to do it 100 more times. Can you visualize that? It's impossible to keep that in your head, and trying to do hundreds of tables together in code is not a good idea either. In fact, this is a typical situation, especially when it comes to data pipelines. What do we do? How do we organize the data? Snowflakes. Yes, it sounds like something out of a fairy tale, but it's a pretty standard concept. Instead of trying to glue all the entities together every time in only code, we can come up with new ones. Say, complex ones, but incorporate simpler ones. We end up with just one composite structure at the top. It binds the less complex entities together. Moving from the center to the edge, the domains become simpler and reach the initial state. How exactly to link the data is debatable and depends very much on the data. And as always, there is one major catch. Since you will definitely want to link the data using keys, think about data updates and don't shoot yourself in the knee by simply deleting data. First, ask yourself, is there a need to delete data? Is it possible to delete all key-related data cascaded, or do I have to? Add a new record in place of the deleted row. Don't get ahead of yourself and think about it ahead of time. So, what do we end up with? It all starts with small nodes that are definitional in nature. Each of them has a unique key when written to the database, by the passport. The next tables, more complex, will contain their own data plus passports of some of the previous, let's call them reference tables. Run, and at the end we get a single resulting table that opens the way to any data. So, what are the perks of being Snowflake? High resilience, easy customized consistency of data matching. Domain model compliance correlates well with the domain model to reduce maintenance and development cost. Versatility, suitable for small and medium-sized projects. Minuses of Snowflake, not suitable for large projects, less adaptable to data chains within large tables. Query complexity, each query must traverse multiple table joins. Difficulties with generation third tables when adding new data sources. Okay, we've sorted out how to do with data scattered across different domains. But what to do with large tables? It's not so complicated here either. Let's dig a little deeper. In any dataset, we always have some central table. Let's call it the result table. Around it, remove other tables that are related to this central table through keys. The main thing here is to realize that the result table uses foreign keys to combine all this auxiliary data into a single whole. If you look close here, it reminds us of our solar system. where the central table is as is the sun and around it revolve tables, planets. In fact, this is a very correct idea because such an approach is called a star. What's entertaining is that on every planet, let's assume this is light on all of them. There will be hundreds of thousands of different species with millions or even billions of individuals. Use the star approach to give database table their own ecosystem. With this architecture, we don't care about normalizing the data. We write everything that it is, which means there are duplicating some comparative structure inside. Where is it convenient to use this approach? Analytics. We get the data in the format in which it was received, and that it is. Not a single user that clicks on the buy button will be missed. A little advice. Since there can be a huge amount of data coming in, save the time of recording and create partition using the data. This will help you understand click times more accurately, process specific days, and reanalyze the data if necessary. It also makes it easier to process outdated data as well as perform various time series manipulations. So, what are the pros and cons that we can highlight? Pros of the star. Query simplicity. Queries to Star are generally simple because it has few relationships between tables. High performance. Queries are executed quickly due to data denormalization and pre-aggregation. Convenience for analytics. Star is convenient for analyzing data because fact tables contain aggregated data. Minuses of stars. Denormalization. Star requires denormalization data, which can lead to redundancy and if there is complexity. Limited flexibility. Changing the structure of a star can be complex and costly. Not suitable for a transactional system. Star is not an optimal choice for transactional systems. So, what to choose? As always, there is no clear-cut answer and frankly, it's not worth looking for one. In all my experience, I have never seen a system that relies on only one approach. The reality is that you need to use what works best for different parts of your system. Most importantly, remember, understanding your data is the key to success. Thanks for watching. It's Eugene from Pynest who was with you as always. Subscribe to our channel so we don't miss any new interesting videos.